Okay, in this example, we're supposed to write this polynomial p of x in factored form if 3i is a 0. Now remember, if 3i is a 0, all imaginary zeros come in pairs because of the quadratic formula where you have that plus or minus. So if 3i is a 0, then we also know that negative 3i is a 0. So I actually know two of them. Alright, now this is a degree 4 and we can't divide out imaginary zeros. We don't have a way to do that. But we do know that if 3i is a 0, x minus 3i is a factor. And if negative 3i is a 0, x plus 3i is a factor. Right? Okay, we know that much. And you know how to multiply, right? You can FOIL this out. And if we do that, we get x squared plus 3ix minus 3ix and minus, well, I should make that better, x. 3ix and then minus 9, what's that, I squared. Look what happens to these two in the middle, right? Here, they add up to 0. And I squared, what's that? Negative 1. So we have negative 9 times negative 1, or really it's positive 9, right? All this makes positive 9. So this is all zeros gone. We have x squared plus 9. Alright, so these two zeros actually multiply out to x squared plus 9. Now, if we take this polynomial and divide that out, we're left with a quadratic where we can find the other two zeros. So that's what we're going to do. But remember, x squared plus 9 is missing the middle variable, right? X squared plus 0x plus 9. So it should be x squared plus 0x plus 9 when we do the division into here. All right, so let's set this up for long division then. X to the fourth minus x cubed plus 10x squared minus 9x plus 9. A little bit long, but we're actually going to divide it by x squared plus 0x plus 9. All right, here goes. X to the fourth divided by x squared. X squared. X squared times x squared, x to the fourth. X squared times 0x, 0x cubed. X squared times 9, 9x squared. Draw your line and subtract. So I go minus, 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 right? Add down, that's a 4. X to the fourth minus x to the fourth is 0. X cubed, negative x cubed plus 0x cubed is minus x cubed. 10x squared minus 9x squared looks to be 1x squared. Okay, then I'll bring the rest down. You can bring one or you can bring both. Then I repeat. Negative x cubed divided by x squared minus x. Negative x times x squared minus x cubed. Negative x times 0x is minus 0x squared. Minus x times 9 is negative 9x. Then we're going to subtract, so add, 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 right? Subtract, that's just the opposite signs. Now add down, 0, x squared, there's 1x squared up here, so 1 plus 0 is 1. That's 0. And then we have 9, so I can have the 0x in here just as a placeholder, and then plus 9. Alright, looks like one more time, x squared divided by x squared, plus 1. 1 times x squared is x squared. 0x, right? And then 9. And as I do this last step here, with the green here, I subtract, and I subtract. 0, 0, 0. I get remainder of 0, which I should, because it said that 3i and negative 3i are both zeros, so I should be able to factor out this quadratic here. Alright, we're left with this now. We just have to find the other two zeros. Well, let's look at this. 1 times 1 is 1, but they don't add up to negative 1. So it's looking to be that maybe these two are both imaginary numbers as well for zeros, right? So let's use the quadratic formula and find them. So minus b, minus negative 1, 1, plus or minus negative 1 squared is 1, minus 4 A, C. A lot of ones in there. 2 times 1. Alright, so let's see here. Negative 4 times 1 is negative 4. 1 minus 4 is negative 3. So it's looking to be that it's 1 plus or minus the square root of negative 3 all over 2, which is equal to 1 over 2. I'm going to split it up. Plus or minus I, or 3, root 3 over 2I. That's probably the best way to write it. These are the other two zeros. Okay, so let's write out our answer then. We have 1, 2, and the other 0, change back to red, would be 1/2 plus the square root of 3 over 2I, and the other one is 1/2 minus the square root of 3 over 2I. So those are the 4 zeros, and what would it look like in factored form? Let me erase some of this, clear it. Our polynomial then would now look like P of x equals x minus 3i, for that one to be a 0, x plus 3i, for that one to be a 0. Tricky. X minus the 1/2 plus the root 3i. So it looks like this. So we have you can put a bracket maybe outside of here, might be better, because it's x minus whatever this whole thing is. So 1/2 minus root 3 over 2i, and the bracket, and then one more with this one in it. X minus the 1/2 again, so parenthesis 1/2 minus root 3, oh, I made a mistake, 2i, end of parenthesis, end of bracket. Then you can get rid of the parentheses by running the negative through, right? So maybe the last step, let me see if I can do it here. X minus 3i, x plus 3i, and then it would be x minus 1/2 minus root 3 over 2i, and then the last one, x minus 1/2 plus, because you have to distribute, plus root 3 over 2i. And that's how you would write the factored form of this polynomial there. The leading coefficient is 1, so leading coefficient is 1.